Good morning, Chapter 8, Lesson 6, page 390. We're going to do some digit and coin problems. These can sometimes be confusing, but again, we're going to go slow and we'll be able to figure out exactly what they're asking us. Word problems can be confusing. Let's break things up into the little pieces and we can figure out what we need to do. With digit and coin problems, one of the things that's going to be confusing is which are the tens and which are the ones places. And if I wanted to represent a number, remember, we would say x is in the tens place and y would be in the ones place. So we could look at this sort of like 10x plus 1y, and that would be equal to the number we were talking about, like maybe 11 cents. Okay? So one of the things we're going to do is 10 is going to be in the tens place, and the y is going to represent the numbers in the ones place. So let's discount this for now. Don't worry about that. I just wanted to write that down to clarify this. And just by example, you'll see what we're talking about. Problem number 1 says the sum of the digits of this two-digit number, the x's and the y's, is equal to 9. Well, that's not so bad. X plus y turns out to be equal to 9. We got that. The digits themselves. If I add up the digits, x plus y is 9. Now here comes the tricky part. If the digits are reversed, the new number is 63 greater than the original number. Well, the first number, if we wanted to write this down, would be 10x plus y. Okay, 10x plus y. So that would give me the number itself. We're talking about like 63 or so. So we have 63 plus 10x plus y has to be, so that's 63 plus the original number. Remember the original number, this was 6 tens plus 3 ones. Well, it's 10 of the x's, we don't know what those are, plus 1 of the y's, and that's going to be the same thing in number 1 if the digits were reversed. Well, if the digits were reversed, it would be 10y plus 1x. So let's stick that over here, 10y plus x. So we got the digits, we flipped them over here, and these are the original digits, 10 times the number of things in the tens place plus y times the number of things in the ones place. So we have this equation, 10x plus y is 63 plus 10 times x plus y. And we have this other equation, x plus y is equal to 9. And this one I'm going to turn into x is equal to 9 minus y. And by substitution, I'm going to substitute wherever there's an x in both sides of the second equation. So here was the first equation. Here was the second equation. So here we go just by substitution, and this part is kind of a no-brainer now that we have that practice. The tough part was coming up with these two equations. So we have 10y plus x is equal to 63 plus 10 times 9 minus y plus y. So I'm substituting here. Wherever there's an x, I'm going to substitute 9 minus y. So let's see what we can do. We have, it looks like 10y plus x is equal to 63 plus 90 minus 10y plus y. So we have 10y plus x is equal to 153 minus 9y. Where did I go wrong? Oh, I forgot to substitute for this x. Let me, well, I'm going to substitute that in here. I should have done that in that first step, but that's okay. So for x, I'm going to put 9 minus y plus 9 minus y is equal to 153 minus 9y. So I have, looks like 9y plus 9 is equal to 153 minus 9y. I forgot to do the substitution on both sides, but that's okay. Add 9y to both sides, I get 18y. Turns out to be 153, take away 9, which turns out to be 144. So 18y turns out to be 144. And lo and behold, y turns out to be 144 divided by 18, and y turns out to be 8. So if y turned out to be 8, 8 plus something is 9, x turned out to be 1. So the number that we were looking for was 1 in the tens place and 8 in the ones place. So the number turns out to be 18. Our solution is 18. X in the tens place and y in the ones place, so the solution turned out to be 18. Just as a review, here is the number flipped over, 10y plus x, and here's the original number, 10x plus y. Okay, let me just highlight that. This is the second number. Here's the first number. Okay, flipped and original. So just grind on through, and we come up with that solution of 18. Let's try number 13, something about bolts. There's this jar, and it contains all these bolts. It has some 5-gram bolts, and it has some 10-gram bolts, and when we add them all up, we end up with 2,350 grams worth of bolts, and there are 300 actual bolts. So we've got x plus y is equal to 300. Okay, and it said they were 2.35 kilograms, and we know from 7th grade 2.35 kilograms is the same as 2,350 grams. So we're just going to remember that. So we've got x bolts times the 5 grams plus y bolts times the 10 grams is going to be 2,350 grams. So we've got the total number of bolts is 300. We got 5 times the number of x's plus 10 times the number of y is 2,350. So let's rewrite these. We have x plus y is equal to 300. We have 5x plus 10y is equal to 2,350. And we could make a graph. We could substitute, or we could add or subtract. And in this one, I think I'm just going to multiply this first one by 5 to see what we can do by adding and subtracting. So this becomes 5x plus 5y is equal to 1,500. This second equation stays the same. 5x plus 10y is equal to 2,350. I think with these two we can subtract. So I'm going to subtract the second one from the first one. So 5x take away 5x is 0. 5y take away 10y is minus 5y. And 1,500 take away 2,350 is minus 850. So we have dividing by both sides minus 5. Y turns out to be equal to 170. So we have 170 of these 10-gram bolts. And if x plus y is 300, then the number of 5-gram bolts turns out to be 130. So our solutions were 130 of the 5-grammers and 170 of the 10 grams for a total amount of 300. That's it for today. See everybody tomorrow.